Hi, welcome back to Mrs. Thompson's classroom again. We're still talking about graphing our trig functions. Today we're going to look at cosine. So let's get started with the basic cosine function. And if we look at our unit circle, we'll remember that cosine at 0 degrees is equal to 1. That means that cosine of 2 pi is also equal to 1. We also know that at 180 degrees, or pi, cosine is equal to -1. So let's start by plotting those 3 points. So at 0, I'll be at 1. At pi, I'll be at -1. And at 2 pi, I'll be back at +1. Now, on the top and bottom of the circle, we get cosine of 90 degrees, which is pi halves, is going to be equal to 0. So we'll mark that right here. And at the bottom, cosine of 270 degrees, or 3 pi halves, is equal to -1. Excuse me, is equal to 0. Good grief. My brain's not on today. Okay, so then we can connect the dots. Now we know from graphing sine in the previous video that these are waves. Okay, we also can remember that this is one cycle, one wave. We call that one period. So my wavelength is 2 pi. But we know that it continues on forever and ever. So not only will I have zeros at pi halves and 3 pi halves, I'll have another 0 over here at 5 pi halves and at -pi halves and at -3 pi halves. And that we'll get these peaks not only at 0 and at pi and at 2 pi, but we'll do it again at -pi and at -2 pi, and it will continue forever in this pattern. Now, one thing we do want to make sure we do with cosine is that when we get to that peak, if that's where we're going to stop drawing, we need to bring the arrow back down. If we end at a valley, we'll want to bring the arrow back up. We don't want to make it look like it continues down forever. This also makes our domain all reals, and our range is still -1 to 1. So our amplitude is still 1. But now our zeros are at multiples of pi half. And in this case, k is going to be an odd integer. Because if odd was even, it would divide out to 2 and make a whole pi. Okay, and then our mins and maxes are out at all the multiples of pi's. So let's see if we can transform a cosine function. So the rules are going to be the same. If we recall from sine, if we have a function like this, A is going to tell me my amplitude because that is a vertical stretch or shrink. The n value is going to find my period because that is a horizontal stretch or shrink. And the C is going to be my phase shift. Bless me. Okay, so for this particular function, my amplitude is 3. My period is going to be 2 pi thirds. And my phase shift is pi fourths to the right. Okay, so I need to, before I start marking my grid, I need to know those things. Now the amplitude is going to tell me what I want to mark my y-axis in. Okay. the period and the phase shift are going to help me mark my x-axis. So the first thing I want to do is I want to get a common denominator. So for 3 and 4, that common denominator is twelfths. So this would be 8 twelfths, and this one would be 3 twelfths. Okay, so I'm going to mark my phase shift at 3 twelfths. I'm going to go ahead and make some half mark here so that I can go far enough. And so I'm going to go in twelfths. So here's 3 twelfths. And that is my starting place. So my start of my first cycle is now going to be at this 3 pi twelfths at a peak. Okay, in general, my start is at my phase shift, comma, my amplitude for cosine. Okay, my end will be at 3 pi twelfths, that's my phase shift, plus my period, also at that amplitude. So basically what I'm doing is I'm taking the point I just plotted and I'm counting over my period of 8. So that would be 1, 2, 3, 4, 5, 6, 7, 8. And yes, indeed, that is at 11 twelfths. Okay? And then this would be 12 would be pi. Okay, now my midpoint, instead of counting over 8, I'm going to count over 4. So 1, 2, 3, 4. And instead of being a peak, it's going to be a valley. And so that ends up being at 3, 4, 5, 6, 7. Now, in order to calculate that, I'm going to take the start plus the end, okay, and I'm going to divide by 2. So that'll give me 14 pi twelfths divided by 2, which is at 7 pi twelfths. Now notice all these calculations with fractions don't change because there's a pi there. In fact, you can just ignore the pi in order to do the calculation and then put a pi next to the result that you get. Okay, so now I need to finish connecting my dots, but I'm going to go ahead and find my quarter point. So I'm going to come halfway in between here. So if there were 4 to get from 3 to 7, I'm now just going to go over 2 and mark my 0. And I'm going to go 2 from 7 to 11 was 4, so I'll go 2 and mark my 0. And then I can connect the dots. And I have 1 cycle. But let's continue this. Let's remember there were 4 between the zeros here. So I can go 1, 2, 3, 4. 1, 2, 3, 4. And then between the zeros was that peak or valley. And so I can continue the pattern. And when you're graphing these, we never want to just do a single period. 2 is minimal, okay? You could do 3 or 4. But we want to we either want to make sure we have filled the entire space. If the period gets really large, sometimes we'll just fill the entire space. Or we want to do a minimum of 2 cycles so we can actually see the wave flowing. And we never want to just seclude our graph to the right side, quadrant 1 and 4, or the left side, quadrant 2 and 3. We want to make sure it spans both the positive and the next x values, positive and negative x values. Okay, let's look at another one. Now here, that n value, the 2, is not divided out. So remember, if in this case, my phase shift has to divide these two things. And the reason for that is because we actually need to get it to look like this in order to determine our period, our phase shift, and so forth. So we have to divide that 2 out for it to work the way it's supposed to. The 2 tells me that my period is 2 pi over 2, which is pi, and my amplitude is 1. Okay, so again, the amplitude is going to tell me how to mark my y-axis. The phase shift and the period are going to tell me how to mark my x-axis. So I'm going to go in 6. So 6 of those would be pi. I'll go in the negative direction as well. So I go 6 in the negative direction to get negative pi. Okay, so this phase shift, now notice this plus means the phase shift is going to the left. We could also just say it's a negative pi 6. So the negative pi 6 is my start, and it's going to start at a peak. So my start is at negative pi 6, 1. Then I'll find my end. So I'll take negative pi 6 and I'll add my period. And that'll actually end up being 1 minus 1/6 is 5/6. But I can also just take this negative pi 6 and go over 6 places, because that's pi is going to be 6 pi 6. So 1, 2, 3, 4, 5, 6 puts me at 5/6, and that's another peak. Now we need to find the middle of those. So instead of going over 6, I'll go 3. 1, 2, 3. And that'll be my valley. And that's my midpoint, which will be at negative pi 6 plus 5 pi 6 divided by 2. Which puts me at 2 pi 6, which is exactly where I landed, which is pi thirds. Right? Halfway in between there, so instead of going 3, now I'll go 1.5, will be my 0. So those zeros in this case are actually at pi 12ths. So I would take, that would be my quarter point, and that would be negative pi 6 plus the 2 pi 6 divided by 2. Or you could do negative pi 6 plus 5 pi 6 and divide by 4. And that ends up giving me a pi 12ths. And then I can connect the dots. And I see one wave. Top to bottom to top is a wave. Okay, and now I need to continue this pattern. So from peak to peak was 6. So I'll go 1, 2, 3. That'll get me the bottom. 4, 5, 6. Going the other direction, 1, 2, 3. That'll be a valley. And then 4, 5, 6 will be a peak. Halfway between were my zeros. And I can connect the dots. And again, with cosine, don't end at the top and make it look like your arrow goes up. Always curve it around. And I mark my 0 and connect these dots on this side. And I'm off my grid, so I'll stop right there. Okay, the last little bit of information I want to show you is what happens if there is a negative out front. Well, this means I have a vertical reflection, or a reflection about the x-axis. So let's take a look at this one. So this one's period, well, first of all, its amplitude is still 1. Okay, amplitude is a distance, so it's always the positive number. So even though there's a negative there, I'm not going to say the amplitude's -1. It is a positive 1. The period is going to be 2 pi divided by a half, because that's what this is here. Okay, so that means my period is 4 pi. And then I'm going to go up 2. I have no phase shift. So that makes my start at 0, 1 normally, but I need to reflect it. And then I need to go up 2. So I end up back at 0, 1, but we need to remember that now this is a valley. Okay, so my end, so that's my start. My end then is going to be at my phase shift, which is 0, plus my period, which is going to be 4 pi. So this is going to be at 4 pi. And again, it's going to normally be at 1, but I'm going to reflect it. And then I'm going to go up 2, so it should end at the same place it started. Okay, so let's go. So we'll make this pi, 2 pi, 3 pi, 4 pi. Again, I can mark my grid however I need to. And this will be here. But again, this is a valley now because of the reflection. My midpoint will be the beginning plus the end divided by 2. So that's 2 pi. And normally that would be at -1, but I'm going to reflect, and that'll be at 1. And then I'm going to move up 2. So now I'm at 2 pi 3, and this will be my peak. So at 2 pi, I'll be up at 3. And my quarter points, halfway in between there, will be at pi. And normally that's at a 0. Reflecting would keep it at 0. And then I'm going to go up 2, and now I'm at pi 2. My other quarter point halfway between 2 pi and 4 pi will also be at 2. And then I can connect the dots. And this is a long, short wave. And again, I'll curve it back up. And I can do the same thing in the opposite direction. So -pi, I'll get all the way down to -4 pi here. Okay. This one will be here. My midpoints, quarter points. And I now have 2 full waves. Okay. All right, so hopefully that's helping now that you've seen sine and cosine. You notice they are related. Cosine is simply a shift of sine, and that goes back to those cofunction identities, which meant that the sine of an angle would equal the cosine of that angle plus 90 degrees, or plus pi halves. So they are shifts by 90 degrees of each other. The other thing to notice is we did everything in radians, and the reason for that is in order to do it in degrees, I'd have to go to 360 on my x-axis. So the numbers get really big. So it's just more convenient to do it in radians. But also, when we think about our unit circle, the radian measures sort of repeat. So I can look at all the pi thirds and know they're the same value, just figure out if they're plus or minus. I can look at all the pi sixths, all the pi fourths. It sort of is this repetitive nature to it, and it helps us understand this cycle that's happening. Whereas when we do it in degrees, we don't see that pattern. Okay, but hopefully that helps, and I will see you next time. Be sure to like below.